talk about an interesting, I'd say, pFET circuit. And at first it looks kind of straightforward and you might think, well, let's see what it does, right? In fact, if you look at the output curve, you might even be almost deceived or thinking, oh, this is just a straightforward transistor curve, while looking at the data that's below me. But let's take a look at this particular device characteristic. It's two devices just stacked together, and they're identical. You can kind of see that the gate and the drain are connected. The gate and what it effectively turns out to be the drain are connected, and the well and the source are connected. And you have two of these. What is probably unusual is that you're actually going to be sweeping the voltage from up top on the source well connection. And what's nice, of course, with pFETs in a typical N-well process is you do get control over the well, so this is an opportunity that you could potentially use. Okay. And we have a number of parameters, and we're not going to worry about sigma in this particular case, or the channel length modulation. So what are we doing next? Well, again, these are pFETs. Remember, pFETs are voltages down from the well. Well, okay, so the well voltage is here going down to this, and that's where the gate is. And the voltage down from that, and so remember that the gate voltage should be subtracted down from the well voltage. So in this case, we're actually saying the well voltage here, the gate voltage is V1, that's where you get this current. And the way we handle the circuit is that the current here is actually sitting through the first channel and through the second channel. So we know they're equal. If you want to deal with KCL, you know that all of that, the two of them have to be equal. But yeah, they're the same thing. The second one's interesting because the well structure is at V1 and the gate and the drain are at 0. So they disappear, and so we get these devices. Interesting kind of structure, because you're thinking, okay, I feel like I'm sitting on my head to make sense of this, and this is kind of getting used to being able to play with different terminals. Well, if you take these two equations, one of the cool things is the currents are identical. I threshold is going to be identical for the two identically drawn devices. Now, if I put different W over L, they could have been different, but nothing was said otherwise that they would be different, so they're the same. And as a result, then, that these two exponentials are the same. If the two exponentials are the same, then the things in the exponentials are the same. And then the kappas go, and so I can get a very straightforward equation that this first expression has to equal the second one. Well, that's a pretty easy thing to solve, and it turns out that V1 is exactly half of V2, or V. And you think, well, that kind of makes sense. I got two devices, so I'm kind of dividing the voltage in half. Not shocking, but it's actually neat to see that that's actually the characteristic. But what's interesting is then when I look at, say, the subthreshold behavior, it gives me something here, and then it's V over 2 in the subthreshold behavior as opposed to V1. I can put it in. I could look at this above threshold, same kind of derivation shows up. In fact, you can do this in a generalized EKV solution below, and that gives you sort of the analytic function. And if you're not familiar with the EKV structure, it's a really nice sort of function that goes between subthreshold and above threshold that can be simplified analytically for the classical above threshold and subthreshold expressions. Very, very useful. So if you do that, you can actually plot what this whole structure looks like, and what it turns out is I get a nice subthreshold region, but this is now kappa over 2 UT. It still breaks at the threshold current, and then I have an above threshold aspect. But this basically acts as if I have sort of effectively I've decreased my kappa by a factor of 2 in the circuit. Very, very useful approach, and very kind of useful to kind of see what could I do with various devices, kind of looking at them just a different approach.